Good morning. Today I will teach you what is the significance of resistance in our electrical circuit. So first of all, what do you mean by resistance? Resistance, we will explain that in terms of a tap of water. Just imagine that when water flowing in a pipe, automatically if something obstacle will be there, the water flow will be decreases. That water flow nothing but in our electrical circuit is current. So current travels in the conductor. So the material having its resistivity, because this resistance is result, that is the by virtue of which is the property of its resistance in that material. So indirectly we can say that resistance is directly proportional to length of the conductor. It will be inversely proportional to area of cross section of the conductor. Because if we see that if the length of the pipe will be increases and increases, automatically the water flow will be decreases. That means the resistance of the pipe will be increases. Similarly here, the conductor is nothing but that pipe. So when your conductor length will be increases, the flow of current will be decreases. That is the concept of resistance direct proportional to length. Again, come to this one, area of cross section. If our area of cross section of the pipe will be more, then more water will be traversed through that pipe. So automatically the resistance will be decreases when your area of cross section will be increases. Or indirectly, if you combine these two, resistance is directly proportional to length by area. Or you can if it will be equal to this one, then automatically this one will be resistance is equal to rho L by A, where rho is the resistivity of the material. And this resistivity is different for different materials. That means if aluminum, the resistivity will be not same as the resistivity of the copper, or that is not same as the resistivity of the silver. So for different materials, this resistivity is different. That's why your resistance is also different for the different material. According to Ohm's law, if you apply the Ohm's law, voltage is proportional to current, or current is proportional to voltage. Or you can simply say that the response is proportional to the source. If your voltage is source, then current is response. If your response is your voltage, then current is source. Or you can say that V is proportional to I, that means it's equal to a constant R into I, and that constant is your resistance of the conductor. Again, resistance depends upon the temperature also. If your temperature will increases, then resistance is also varies with temperature, and resistance varies with temperature as RT equal to some R0 1 plus alpha T, where R0 is the known resistance at a certain temperature, alpha equal to temperature coefficient or a coefficient of the material, and T is the temperature difference. So this alpha value is constant, that is the fixed for your temperature coefficient, that is for material it will be already fixed one. The T is your capital T is the temperature difference. That means if we know the resistance at 25 degrees centigrade and I want to calculate that at 50 degrees centigrade, then this RT value equal to the resistance at 25 degrees centigrade into 1 plus temperature coefficient of that material into 50 minus 25. That is the answer. We will get the resistance at any temperature. We can say that. Next we will see the resistance in series. If n number of resistors are connected in series to a particular voltage source V, then what happens? This is a total series circuit. That means series circuit means what? The current is sent through all the circuit element where voltage is different. So a single current I that travels through all the resistances in the circuit. So automatically the V equal to total voltage equal to I into some R equivalent. Voltage across R1, V R1 equal to I into R1, V R2 equal to I into R2, and that similarly V Rn equal to I into Rn. If we add all the voltages that is similar to total voltage V, so V equal to V1, V2 up to Vn. So I R equivalent equal to I R1 plus I R2, taking common I, or getting cancelled in both sides, R equivalent equal to R1 plus R2 plus up to Rn. So whenever the resistances are connected in series, the total resistance that will be calculated as the summation of all the resistance across that series path. That is the resistance in series path. So when we consider resistances in series, the voltage division, another extension of this one is voltage division. Let a circuit that will consist of two resistors R1 and R2, both are in series to a single voltage source V. So automatically the voltage across R1 equal to I into R1 and voltage across R2 equal to I into R2, whereas I equal to V by equivalent resistance of the circuit, which one equal to R1 plus R2, because these two are in series, then the total resistance R equivalent equal to R1 plus R2. So I equal to V by R1 plus R2. Putting this result in our first equation, V R1 equal to, instead of I, V by R1 plus R2 into R1, and V R2 equal to V by R1 plus R2 into R2. So we can check this one is the voltage across R1 equal to the same resistance. Voltage across R1 equal to the same resistance divided by the total resistance or the summation of two resistance into total voltage V. Voltage across R2 similarly equal to R2 divided by total resistance into total voltage, that is V. So this is called voltage division in series circuit. If our total voltage is known and the resistances are known, we can calculate the voltage across R1 and R2 individually. Then we go for voltage in parallel, resistance in parallel circuit. Actually, what is meaning of series circuit and what is the meaning of parallel circuit? Series circuit, how do we know what is a series circuit or which one is the parallel circuit? If our same current travels through the network elements, then all network elements are connected in series, because the same current passing through all the circuit. Similarly, parallel means a circuit is parallel. How it will be calculated? If the circuit, two circuit elements having the same voltage, then it is called parallel. So likewise our figure will be like this one. So this is a parallel circuit because the same voltage V appear across R1, same as appear across R2, and same voltage appear across Rn. So this R1, R2, all these circuit elements are connected in parallel. So if we will solve this one. The total current is I1 and the current in this branch is I1, I2, and in the last branch that is In. So in parallel circuit, what happens? Voltage is same through all the resistance, but the current is different. While this in series circuit, current is same in all the circuit elements, but voltage is different. So in this circuit, total voltage equal to I into R equivalent, or I equal to V by R equivalent. I1 voltage across current through resistor R1. I1 equal to voltage through resistor R1 divided by this resistance, so V by R1. According to Ohm's law, V equal to IR, that means I1 equal to V by R1. Similarly, I2 equal to V by R2, and in total up to IN equal to V by Rn. So if we add all this current I1, I2 up to IN, then we get the total current I, because the summation up to V by Rn, taking common V 1 by R1 plus 1 by R2 plus 1 by R1, or you can say that cancelling V 1 by R equivalent equal to 1 by R1 plus 1 by R2 up to 1 by Rn, or if we take the reciprocal of resistance, that is conductance, G equivalent equal to G1 plus G2, where G equal to the conductance of the material, which is the reciprocal of resistance. The reciprocal of resistance, because conductance means it will allow your current, and resistance it will oppose to your flow current. So the reciprocal of resistance is called our conductance, which in parallel circuit G equivalent equal to the summation of all the conductance present in that circuit. In series circuit, like series circuit, R equivalent to R1 plus R2 plus up to Rn. In parallel circuit, G equivalent or conductance equivalent equal to G1 plus G2 up to Gn. So here you are in parallel circuit, if we will check that what is the current flowing, actual current flowing in this circuit, then we go for current division. So in current division, just we take these two resistors R1 and R2 in parallel across a single voltage source V. A single voltage source V, total current is I, current through resistor R1 equal to I1, current through resistor R2 equal to I1. So I1 equal to V by R1 in these two circuits, R1 and R2. R equivalent equal to 1 by R1 plus 1 by R2. So when you simplify this one, you can get R1 plus R2 divided by R1 R2, reciprocal of this one, or that is equal to R1 R2 divided by R1 plus R2. So if two resistors are in parallel, then the equivalent resistance equal to simply the multiplication of these two resistors divided by the addition of these two resistors. Multiply R1 R2 divided by R1 plus R2. So if we get I equal to this value, then I1 equal to V by R1. So V divided by R1 R2 into multiplication of R1 plus R2. Or we can say that V, if we consider in V equal to I1 R1, so that is equal to V into, because if we consider V equal to I1 R1, then not only I1 equal to V by R1, so V equal to I into R equivalent, this V equal to total current I into R equivalent equal to R1 R2 divided by R1 plus R2. Total voltage equal to I into R equivalent. So I into R equivalent value is this one. So when you go for I1, V by R1, so we put this V value in here. Then we get I1 equal to V means this value I into R1 R2 divided by R1 plus R2 divided by R1. That means R1 get cancelled and I into R2 divided by R1 plus R2. Similarly, if we go for I2, then the same result I R1 R2 divided by R1 plus R2 divided by R2, which we get I into R1 divided by R1 plus R2. So the current division from this equation we can check that the current division will be I1, that is equal to the opposite arm resistance divided by the summation of two resistance. That means I1 equal to R2 divided by R1 plus R2 into our total current. Similarly, I2 equal to opposite arm resistance R1 divided by R1 plus R2 into our total current. This is the current division in our parallel circuit. किस में है? हाँ?
कितना है? 14, 15 मिनट है।
हाँ है ला।
बंद।